Same thing as yesterday, but with calculator, which is much easier than table A. So if you didn't like table A, yay. It's going to be better today. All right, according to the CDC, the heights of 3-year-old females is normally distributed with a mean of 94.5 and a standard deviation of 4. Now, we can only use normal things like table A and what we're about to learn on our calculator if we know the distribution's normal. For now, they're going to be like, hey, the distribution's normal. Eventually, we're going to learn ways to check if the distribution's normal, all right? But for now, they're going to give you normal distribution, which means you draw a lovely symmetric curve like this, bell-shaped. We're going to put 94.5 in the middle, and we are going to add a standard deviation of 4 3 times and subtract standard deviation of 4 3 times as well, all right? About what proportion of heights are at least, bless you, 90? Bless you. Oh, bless you. All right, 90 or more. So many sneezes and stats. Okay, so on your calculator, it's going to do this for us without table A, and you don't have to subtract from 1 anymore for greater than. So that's why this is like way better. So go to your calculator, go to menu, go to statistics, go to distributions. You're going to be here a lot in this class, distributions. We're going to do almost all of these, so many of them, all right? But we will never use number 1, okay? We will use norm CDF and inverse norm today. So norm CDF is the normal curve, okay? It asks for the lower bound and the upper bound. So we're going to look at, we want at least 90, which means 90 or more. We also don't have to convert to z-scores anymore. Now, when I do 90 or more, you just put a really big number in there, okay? Like, you know how it kind of goes to like 3.5 or 4, right? But just put in like 10,000, all right? A big number, all right? So from 90 up to a big number. And then we aren't going to use 0 and 1 because they have a mean and a standard deviation. We don't have to standardize our data anymore, all right? So now my mean is 94.5. So I'm going to plug in 94.5. And they told us our standard deviation was 4, so we plug that in and we press OK. Now, to earn full credit on the AP exam, you have to label each piece. So you are allowed to do norm CDF, lower bound 90, and I should just be writing this in one big long line, but I ran out of room. Upper bound 10,000. Oops, I put an extra 0 on there. All right, and then my mean, you're going to put mu. You have to label it, 94.5. And then my standard deviation, you're going to put sigma and plug in 4. Okay, norm CDF greater than 90. Oops. And we got about 87% of 3-year-olds are at least 90 centimeters tall. Okay, about what proportion of heights are less than 92? So again, you would draw your curve. You would find 92 right here. And we would shade less this time. So I'm finding the proportion of 3-year-olds, whatever you want to label your variable. We'll just say X greater than 92. They'll put that in the book sometimes, okay? And we're going to do norm CDF on our calculator. This time, what is my lower bound? Negative a big number, okay? It technically goes forever to the left. So it kind of looks like 82.5, but don't put that. Put negative 10,000, okay? If you are doing less than a number, negative 10,000. And we're going up to 92. There's my upper bound. My mean is still 94.5, and my standard deviation is still 4. And we plug that into our calculator. And did you guys get it? 0.26. So about 26% of 3-year-olds. You guys, I wrote greater than, and you guys just let me. All right, this is supposed to be less than. I just figured it out when I was going to say what we're talking about, right? All these 3-year-olds that are less than 92 centimeters, 26% of them. All right. Now let's do an in-between one. About what proportion of these 3-year-olds are between 90 and 98? So again, you would label your lovely graph here. We would go 90 to 98. Okay. And we would do norm CDF. My lower bound is 90. My upper bound this time is 98. And my mean is 94.5. And my standard deviation is 4. Did you guys get about 68%? Awesome. Okay, great. All right, and if you were writing this for like probability of, we're finding the probability of how many of these 3-year-olds are between 90 and 98 centimeters. So it would look like that if you wrote that proportion statement. All right, what is the 80th percentile of heights for 3-year-old girls? So 80th percentile would mean you're taller than 80% of your peers, right? So 80%, again, I'm kind of like estimating 80% of my graph if I shade about 80%. Now, this is super nice because we don't have to convert between the z-scores. We can just plug in the answer and get it. It's so great, okay? We don't have to go back and forth, but do remember there is a corresponding z with every single percentile, all right? Now, because they gave us the percentile, we are going to use inverse norm on our calculator. All right, inverse norm is going to tell me the value down here that is at the 80th percentile. So we go back to our calculator, we go to menu, we go to statistics, we go to distributions, and this time we do number 3, inverse norm. Again, we will never use number 1, but 2 and 3 we'll use. My area is going to be 0.8, okay, for 80th percentile. We are going to change the mean, otherwise it gives me the z-score. So my z-score, or sorry, my mean was 94.5 from this lovely problem, and the standard deviation was 4. This will tell me the value at the 80th percentile, which is 97.9. All right, and this would be in centimeters. So again, I'm finding the value down here. This is the height of this kid who is at the 80th percentile. Yes. Yes, we do have to do this. Yep, here I go. All right, so here's the work you would need to show. All right, you have to write the word area. You have to write inverse norm, all right? And then you got to write area is 0.8. You got to write the mean is 94.5. And you have to write the standard deviation is 4, and then your answer, okay? So yes, you do need to show norm CDF, inverse norm. If you don't label everything, if you plug it in like this, you will lose points on the AP test, so just make sure you label everything, okay? A lot of people forget that because the calculator doesn't show it, right? So make sure you label it, yes?
What if you just say A for area or L for load?
I think you should say area, just in case. All right, how would you find Q1 and Q3? What is Q1, you guys? All right, it would be the 25th percentile. What's Q3? Right, so what kid, what's the height at the 75th and the 25th percentile? These are percents, so am I using norm CDF or inverse norm? Inverse norm. So I'm going to do inverse norm, area 0.25, mean of 94.5, standard deviation of 4. And if anyone plugged that in, what height is at the 25th percentile? 71.8? That would be small. All right. 91.8. Great. And then we would do the exact same thing. I'm not going to rewrite all this, but you would plug in 0.75, right? And we would find that height. Okay? Everybody good? All right. Yay. Oh, okay. It's only the front side today, so it goes really quick. And it's your calculator.